Hey there, man, Alejandro. Welcome back for day 149 of me doing the NeetCode 150 challenge. So today we're doing a very last LeetCode hard 2D dynamic programming problem. And without further ado, let's get straight into it. Okay, today we get LeetCode hard problem number 10, regular expression matching. Okay, given an input string S and a pattern P, implement regular expression matching with support for dot and star, where dot matches any single character, star matches 0 or more of the preceding element, right? A dot is a single, yeah. The matching should cover the entire input string, not partial. Okay, so I have a little disclaimer for this. First of all, regex are cool in the sense that I took a course CSC B36 at the University of Toronto Scarborough. I think it was called Theory of Computation, blah, blah, blah. And essentially our professor Nick Chang was the big result is that essentially any regex can be made with a DFSA can be made, and NEFSA, NFSAs are no more powerful than DFSAs. So a DFSA is a deterministic finite state automata. An NFSA is a non-deterministic finite state automata. So there's multiple possible options, which DP is excellent for. So I already have kind of a general gist of how I'm going to solve this problem. But in case I get stuck, one thing, and I don't know if I'll end up using it here, is I can go to my good notes on my iPad, which I have over here. And if I go to the section where I learned about the Floyd-Warshall algorithm, Floyd-Warshall, assume no negative weight cycles. Yeah, so this I to j k-path idea. Yeah, so I don't know if you guys can see. Let me zoom in here. So, okay, let me bring this up to the camera. Maybe I should make my thing a little bit bigger. There, so now you can see me nice and properly. So let me try to hold this as much as I can. So these notes, over here specifically, it's essentially he was showing us that the way that regexes are made uses the same I to j k-path idea from the Floyd-Warshall algorithm that I really love down over here. So R of ijk, essentially it's R of ijk minus 1 plus of ij k minus 1 with a star, so on, so it's maybe this can help us with a recursive formula, which would be pretty darn cool. I just remember my professor Vassos Hatsilakos talking about that. The only reason I know that sounds super random, is Floyd-Warshall algorithm is one of my favorite absolute algorithms, if not my actual favorite algorithm, for the simple, in terms of an algorithm, it's just it's a boring triple for loop. It's what the heck is so special about this? But the intuition that comes behind that algorithm is just labeling nodes from 1 to k in any way you want, and essentially abusing that mechanic to find all pair shortest path. I really love that idea behind the algorithm, and this one might be exciting because it seems like we might end up using a similar type of idea. Okay, so given an input string S and a pattern P, so let's see an example. So A, false. A does not match the entire string A. A star, yeah, means 0 more. So you have essentially many options, right? So here what I'm going to do is we're going to have a DP. We're going to have probably an index I and an index J for index X and index P for P, right? Here we can say S index, P index, right? Here we could probably put a cache decorator. Here we'll say I, J. I represents current index in input string S. J represents current index in pattern string P. Okay, so first of all, if I is greater or equal to, so here we'll say self.s self.p is equal to s comma p. Also, let me just, there we go. Okay. So I'm currently in my lunch break at work, so it's currently 12:14 p.m. I decided to essentially start my lunch break a little bit 10 minutes in, although on the side I'm currently waiting on a PR to get merged and so on. So in case someone approves that, I want to make sure that I'm essentially able to run a build to get that deployed while I'm on my lunch break, because that's the most annoying part of the job, which is just waiting for deployments to happen over and over. Since this is just like, a tiny button click, I can just do that on the side. And since it's my lunch break, I get to work on LeetCode. Actually, I was in the mood to work on LeetCode today, so that's why I'm doing it now. But if I don't solve this problem within the next 45 minutes, then I will have to stop. Okay, so self.s, self.p, s equal p. Yeah, so if I is greater or equal to length of self.s, then we found a valid solution, so return true, right? If j otherwise is greater or equal to length of self.p, assert I is less than length of self.s, and return false, right? Sweet. Right, otherwise we have many options. Yeah, so we need to check a few cases, right? Which is like, well, we'll never be at a star. I will make sure of that. So, okay. Case 1. Index plus 1 to a star. J plus 1 less than length of self.p, and self.p of j plus 1 equals star. Then we have big time trouble, right? So we need to come up with a lot of cases, right? To do, implement this. Right here, I'll just do assert false for now. Okay, so now we can just put that as a to do. Raise exception not yet implemented. Okay, kind of like work. All right, here we'll just say, okay, so now we're just gonna move on from that, but the point is that essentially we're gonna have the option of doing 0, 1, 2, 3. What's the time complexity for this? Oh, they're 20, 20. Okay, we can go as inefficient as we want. Previous valid characters to match. Okay, beautiful. So they're not going to give us an invalid regex. Yeah. Well, first of all, if letter S, letter P is equal to self.s of I, self.p of j. If letter P equals a dot, that's not for me, so that's fine. Return, what should I return? True. Yeah, if you have dot star, you can match anything, right? So GG's. Okay, so that's just a little triviality case. Otherwise, if it's a dot, you're just gonna move on, right? Letter P equals dot, then we'll say return self.dp, move on one index and one index here, right? Otherwise, if letter S doesn't equal letter P, return false for this case. Otherwise, here we're going to say insert letter S equals letter P and return self.dp of I plus 1, j plus 1. Right? Or here we can really just say return letter S equals letter P and self.dp of I plus 1, j plus 1 is really what we can do. Okay. Kind of a thing. Okay, so we might pass one of the test cases. We might not pass the one where this is here yet. Okay, yeah. Here we're just going to do a return self.dp from index 0, 0. This might actually be a really easy problem. We might not need the complex regex that was presented. Yeah, well, that obviously needs a self, yeah? Okay. Yeah, raise exception. Okay. Here we'll just do return false for now. Right? Okay, so yeah, so this one's true because they don't have any dots, any non-dot stars, right? Otherwise, yeah. Otherwise, we gotta do, so you can either do 0 characters, you can do 1 character, you can do 2 characters, right? So, letter P. While true. Can select 0 or more instances, letter P, match with S. This one, like 0 letters. If self.dp of index I and j plus 2, right? Get through the star. Get through the star. Right, so it's like the current letter P is like, you know, A and star. It's like get through the 2 of those. Return true, right? There we go. Otherwise, we'll say while index is equal to I. While self.s of index is equal to letter P, if self.dp, we're going to say x plus or equal to 1, self.dp of index j plus 2, true, plus 1, index plus or equal to 1. Next, j index equals j plus 2. Okay. While index is less than the self.s, if index are equal to length self.s, return true. Alright, that's just an easy one. Yeah. Actually, this is just, we shouldn't need this. Okay, first of all, let's run something like this. Okay, that's accepted. Let's submit. Okay, wrong answer. Let's just see. Yeah. Ah, dot star. Yeah. Yeah, here what we should do is this. Letter P equals dot, right? So that's essentially like a bypass mechanic. No, eh? Maybe there should be return length of self.p. We should have matched the full regex, right? Well, that's that index. Okay. Index less than length of self.s. And this. Uh-oh. Infinite loop? That's not me. MLEA. Okay, now submit. Wrong answer. Okay, what's going on here? Yeah, this should be a true. This is the one that should get triggered right here. We don't pick any letters. That's not me. Okay, I have 30 minutes of lunch left. And X less than that. Okay. Almost there. 0, 0, 1 with 1. Yeah. And true. Just gonna make sure we actually get into this case. Yeah, so the fact that we hit it tells me we do. Come on, run. We do not hit this case. J is equal to 1. 1 is a B. What? J plus 1 is less than length of self of P. Equal to a star. I need to mute this. This should be true, right? F string. Yes. Oh my gosh, I hate this. What the hell is going on? star. One. Ah. What? If this turn true, LF not allowed to add any more characters. Hence, must be of char equals star index or index in range j plus 1 length of self dot p and go by 2. Ooh. This is interesting. Okay, that's a janky little hack for now. Let's see. 331, eh? Yeah. While j less than length of self dot p, if it is not the case that j plus 1 is less than length of self dot p and self dot p j plus 1 equals star, then return false. Otherwise j plus or equal to 2. We can do something like that. Return true. Okay, now submit. There we go. Bada bing, bada boom. Okay, I'm so used to the daily being like, completion streak, whatever, so days. But there we go. Okay, we have a working solution. Yes, okay, so this is a lot, well, it took a few edge cases, but yeah, this is a lot simpler, and we didn't need the overkill, like, Floyd Warshall algorithm, regex pattern stuff here and so on, which is probably more useful for, like, actually, like, complicated regexes with, like, all the possible symbols and so on, blah, 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 blah. Or, like, probably a way of solving this problem a little bit better, right? Yeah, so I to k, k to k, k to j. It's probably a way to solve it, at least maybe with like a faster time complexity. But the point is that we were able to do it. So there we go. That's all I care about. And I saw the constraints were not that large in the first place. So there we go. Yeah, nice. Although yeah, so now we're a little bit slow. We can do a bit of things like self.memo is equal to this. If I, comma j in self.memo return self.memo of I, comma j. Right. Is equal to false. Yeah. Is equal to true. And true. Is equal to false. Right, we'll get rid of all the... Okay, first of all, one easy addition that we can make before we do any self.memo stuff. Because, okay, yeah, first of all, if we don't cache, we die, right? That should just be obvious, yeah, okay. Well, we don't even die. We just, like, there we go. Prints will become hashtag prints. There we go. Do we still have things running? Print. Well, first of all, what is going on here? Okay, let me go to the next print. Print this, not useful. If this then print that, then that's not useful. This is a print true, this is not useful. This is not useful. Case 2, pick one or more letters. Case 1a, case 1b. There we go. Letter or letter P equals dot. There we go. Case 2. Index j plus 1 does not map to star. Just check. The simplest case. There you go. Yeah, this can be commented out. Okay. This can be put there. Yeah, here we'll just make an aleph. N comma m is equal to length of self.s, length of self.p. So well, this is m. And this is n. S. Yeah, so let's put this. So we're equal to n. go. Put a space at the end. Do a little run here. Okay, submit. And there we go. Okay, 7ms beats 69.28% of solution, so that's already faster. Now what happens if we put a self.memo, right? If I, j in self.memo, return self.memo of I, j. Right, otherwise here we'll just say self.memo of I is equal to false. Right, self.memo of I is equal to true. Is equal to false. Now we'll just say is equal to true. This is equal to true. Is equal to this. Return self.memo of I, j. Try something like this maybe. Is this a little faster? Just the same. Returns. Let me just make sure I have a memo in front of every return. Yeah, memo, 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 memo. Yeah, so here, if anything, we can just do res is equal to res, return res. Right, maybe this is a little faster. No, it brings me to 8ms. Okay, I'll try one more time. Yeah, here, you know what? We'll just do things like this. We'll get rid of self.memos everywhere. Deck. Here. Here, here. Plus it just clogs up the code. There we go. So here if we submit this, this should not be fast at all. But now we'll put a cache decorator. And we'll resubmit, making it a little bit faster. Yeah. Oh, it actually does patch even without it. It's just that, yeah, because the cases are so small. But if we put a cache decorator, things are nice and crispy. 3ms beats 94.41% of solutions, which is absolutely what we love to see, ladies and gentlemen. Okay, so nevertheless, as always in my videos, I do a quick recap of visible style of problems. So this is a pretty fun one. I thought it was actually going to be a little bit more complex, just because, again, as I was saying earlier in the video, one of my favorite algorithms in the world is Floyd-Warshall algorithm, even though it's just a regular triple for loop, because of the intuition behind the algorithm with the I to j k paths, where you label nodes between 1 to k to essentially, like, you know, figure things out. And essentially, our professor told us that, like, you know, for regexes, it kind of follows a similar pattern, and it was kind of like, you know, part of the intuition behind the Floyd-Warshall algorithm. And so I thought, like, you know, maybe I would have to do something a little bit complex with I to j k paths, but turns out to solve this problem I could do something a lot simpler. So the problem itself is essentially you want to implement a regex parser where you can only have, like, you know, characters in a pattern, the dot character as well as a star character, right? And so the reason why DP is just so nice and beautiful here is due to the fact that you can make choices, right? Where it's like, okay, if I have like a dot star, it's like, you know, I can either match 0 of it, 1 of it, 2 of it, 3 of it, 4 of it. The point is you don't know, so you try them all, right? But since you memorize, you never end up doing, like, you know, more than n squared total subproblems and so on, and then depends on the time per subproblem, yada, 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 it ends up being a little bit much more efficient, I should say. So the way that I did this is essentially, it's like, okay, I do 2D DP, kind of like, you know, as was hinted to us by, like, you know, the fact that this is a 2D DP problem, where my two-dimensional parameters are the current index in string S and the current index in string P. So here's how I go about it. First of all, I grab the lengths of S and P as N and M respectively. Here I'll say, okay, if I is greater or equal to N, that means we've matched every single character of the string S. If this is the case, then I need to have at least either exhausted all of string P. If you think of, so again, regexes can be mapped to any deterministic finite state automata, but, like, you know, you need to be at, like, you know, one of those n nodes inside of your DFSA, which in this case is, like, you know, matching the entire regex, or, like, you know, being at an infinite star loop where we can just continuously put 0. So this is exactly what I mean. If we've exhausted every single character in S, we want to essentially have exhausted our pattern P, right? But So first of all, if like, here we'll say while j is less than m, if j is greater or equal to m, i.e. we've exhausted all of p, then we just return true straight up, right? Like, if both I is greater or equal to n and j is greater or equal to m, we're done, right? We've exhausted every single character in S, every single character in P, we are just done, right? But let's say, right, you have something like, I think it was one of these cases. I could actually pull them up. Yeah, something like this. Yeah, so let's pull this example up. You know what, we're gonna come down here. Let's say we have A, right? And this is our current index I here. And we also have a B star for our string P, right? P is equal to, S is equal to A. And we're currently at that index. And here we're currently at this index, right? Here we'll say, okay, great, we have a character A. Here it's like, okay, we have a character A. All right, for now, just trust me, like, you have no other options. There's no star here or anything. So here's like, you must, validate these A's together. And here we're at a point where we've reached the end of the string S, but we haven't reached the end of the string P, right? So you might think like return false. Well, in this case, we don't want to return false because we have a B star, and star, remember, means 0 or more of this pattern, right? The plus sign is the one that's 1 or more, and we don't actually have to support the plus sign here, which is just great. But we have the star sign, which means 0 or more, which means I can pick 0 B's, right? So this pattern would indeed be true. And you don't want to check for just one star, right? You could have like, B star, B star, B star, C star, D star, K star. You could have a lot of characters with stars, and for each of these you could just pick 0, 0, 0, 0, 0, 0, 0, right? So that's why I have a little while loop here that says, okay, while j is less than m, I want to make sure that, like, okay, if you're not at the end of the string pattern P, make it such that there's a character followed by a star that I can pick 0, right? So if it is not the case that the next character is a star, i.e. j plus 1 is less than m, and self.p of j plus 1 is equal to a star sign, then I just return false, right? Because you've not exhausted all of P, and you don't have the option of picking 0 more characters, so you return false, right? Otherwise, it's like, okay, for example, here I saw B star, so I'm like, okay, cool, let me update my j by 2 more and continue checking from there, right? So here, if I have B star, then it's like, oh, I must enforce a B, I would return false at this point, right? But the point is, I keep going through this while loop, and at the end, if I get through this and everything was a character star, then it's like, okay, I could have picked 0 for everything, or if there was nothing in the first place, j was already greater or equal to m. Regardless, I will just return true because I am indeed able to exhaust the pattern P, right? Otherwise, if I is not greater or equal to n, there are still more characters for us to pick. So a trivial base case is like, okay, if we've exhausted the full pattern P, but we haven't exhausted the full string S, return false, right? So that's just a simple case right there. All right, so enough for the base cases. Otherwise, it's like, okay, index I is less than the length of S, which is n, and index j is less than the length of p, which is m, right? So in that case, it's like, okay, grab the letters at these two strings. So here, case 1, which is the harder case, is if index j plus 1 maps to a star, right? If we are a current character in our pattern, but the next one is a star, that means we can choose 0 or more occurrences of this pattern, right? So maybe I should start with case 2, which is the easier one, which is when it's not the case that, j plus 1 is less than m, and delta p of j plus 1 is equal to a star, right? If our next character is not followed by a star, then it's like, okay, we can only continue if the current letter is match, right? For example, over here, we were lucky, right? Like we had an A matching with an A, right? And the next character was not a star. So it's like, okay, here we can proceed. Or the only other way to proceed, if this is not the same character, right? If this was a K, you can't proceed. A and K are not the same, so you return false. But if this is a dot character means you can match any single character, right? So if it is the case that letter of S is equal to letter of P, right? Or that letter of P is a dot symbol, meaning I can do any character, then and only then I can proceed, right? Here I have an AND check, and if this condition is not satisfied, then the AND of this whole thing will just be false, right? Otherwise, if this is true, like either the characters match or the current letter at self.p at index j is equal to a dot character, then I can say, okay, let's augment the indices of these two guys by 1, and then keep checking the problem rest recursively from there, right? So, and self.tp from index I plus 1 and j plus 1, right? Otherwise, the harder case will be when index j plus 1 does indeed map to a star, right? So in this case, we can have 0 more occurrences, which is a little bit harder, all right? So the very first thing I do is like, okay, we know that we're going to have something like, here, let's come in here, right? Let's pretend we have a K, right? Here we have a B star, right? So what does this mean? And for now, let me just get rid of all this nonsense over here because it's just not useful. Okay, suppose we have something like b star. Okay, that means we can grab 0 more occurrences of b, right? And we'll need to do it over here. But then once we're done with it, we'll have to get rid through this b star, so we'll increment our index j by 2, right? So this is why I'm going to set over here that my index j, next index j will be index j plus 2, right? So that once I'm essentially done with matching like the b star pattern, right, I just go through it and so on. But the point is I'm going to handle this case now. So 0 more means I can either pick 0 or more than 0, right? So case 1 will be pick 0 letters, right? If I want to pick 0 letters, then I stay at the same index I in my current string s, right? And then I pick, and then I continue on from j plus 2, right? Which in this case would be exactly what we need to do, right? Here we have a k, which is not matched with a b, so we 1k possibility is like, okay, we pick 0 b's, right? Which means we would go from here, essentially do nothing here, because it's like, okay, here we'll just do 0 b's, right? Otherwise, here we'll see that, for example, a case like this will be false, right? Because here we're at the end of the string p, but we're not at the string s, so we're done, right? But now let's pretend this is a b. We don't want to pick 0 b's, because then we get to this case, which is just false, right? So here we'll say, can I pick 0 letters? And if so, return true. In this case, it's like, okay, picking 0 letters would still leave me with a not done string s, so I can't do that just yet, right? But I can definitely pick 1, right? So that's kind of the point. So here what I'm going to say, oh, actually, one way I could have done this is instead of like, going fully, I could have just done it more recursively. But okay, that's just a little implementation detail. Yeah, I could have. That's okay. That's okay. So here we'll say, okay, otherwise we'll pick 1 or more letters. So here we'll say index is equal to I, right? While index is less than n, and it matches the current letter, right? So here we're going to match as many letters as we can, however many B's we have, but we're going to do many cases. We're going to do the case of 1 letter match, 2 letter matches, 3 letter matches, right? The point is with, we don't know how many B's to match, right? We don't know what our regex is and so on, so we could do the case where we match 0 B's, 1 B's, 2 B's, 3 B's, 4 B's. We don't know how many B's to match. Do we match them all? Do we only match half? Do we match 3/4? Do we match all of them except 1, right? Like in order to get a valid regex. This is where DP comes in, because we're like, we don't know which case to do, so try all the cases and see if any one of them return true, right? So here we're gonna say, okay, as long as the character matches, right? As long as like, the current index, starting at index I, matches the current letter P, right? Which is followed by a star, remember? Then it's like, okay, we can keep doing that case, right? Or letter P is equal to a dot, because like, that means you can pick any character, right? Then we'll say, okay, as long as it's still true that starter index is equal to P or letter P is equal to a dot, let's try the case where we move the index by 1. With the next index, we're done through the dot star. And if that happens to be true, then we'll return true, right? Otherwise, index plus or equal to 1 and keep checking, right? So essentially what I'm doing here is check the case where you do only 1 B. Then check if that didn't work, check the case where you do 2 B's. If that didn't work, check the case where you do 3 B's. If that didn't work, check the case where you do 4 B's and 5 B's and 6 B's until there's no more B's, right? Or if letter P is equal to a dot, like, do whatever you want. But the point is that I'll exhaust every single possible case, right? That's the beauty and magic of DP. I don't know which case to do, so try them all and see if any of them works, right? And that's pretty much it, right? Again, case 2 is the case where it's like, the current characters were not followed by a star. So like, this is the harder case, right? And so the point is like, just return true if anything works. Otherwise, just return false at the end of the day. And yeah, there we go. Beauty. Here I wonder, can I do an else? Does this work? Yeah, no. This is just going to be a nice little base case. All right, there we go. Okay, sweet. But yeah, that's pretty much it in terms of how I was able to solve this problem. And if we submit it, we can see that it is a nice, crispy, and efficient solution. Okay, so now we get 9 MS, but before we got 3 MS. We can submit one more time, see if it's a little bit more efficient. Yeah, 7 MS, okay, but we're in that range, which is nice. So nevertheless, as always, we can come over here and check off the fact that we did this problem, which feels absolutely incredible. That's the last 2D dynamic programming problem. We're at 20 out of 21 hards, which means we're at 149 out of 150 NeetCode problems done, which feels absolutely incredible. Heck yeah, I cannot wait for the next one. But yeah, but otherwise, that's pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you next one. So till then, ciao, ciao, my friend. Bye-bye.